Hello friends, in the present video, we will see the factors that are affecting the ultimate bearing capacity equation. Okay. Factors affecting the ultimate bearing capacity. So if nothing is mentioned, that means we are using Terjagi's theory only. Always remember this point. Can you recall the equation? What is the ultimate bearing capacity equation QU? That can be written as C into NC plus gamma into D into NQ plus half into gamma into B into N gamma. So this is the equation for ultimate bearing capacity for the continuous footing, or we can also call it as a strip footing. Remember, either in exam they will give you either continuous footing or else they will give you it as a strip footing. Both are same. Now, let us see the effect of unit weight. So how many terms we are having the unit weight in this equation? We are having unit weight in gamma D and Q, and also we are having unit weight in gamma B and gamma. Let us assume if your soil is getting more compact, that means it is very dense soil. Okay, compare the dense soil and the loose soil. For the dense soil, it will have more unit weight. Loose soil, it will have the less unit weight. So if your gamma increases, in this equation, obviously your ultimate bearing capacity will also increase. If your weight density decreases, then also your ultimate bearing capacity decreases. It is directly proportional, isn't it? Suppose if you are having a soil, it is under submerged condition, then what will happen? Instead of taking the unit weight, we will consider it as a submerged unit weight. So how will find the submerged unit weight? We will neglect the 9.81 kilonewton per meter cube. That means if water table present at the site condition, because of that our weight density will decrease. If your weight density is decreases, then your ultimate bearing capacity will also decreases. Okay, so this is the effect of unit weight on the ultimate bearing capacity. Now let us talk about the depth of the footing. So in how many terms we will see the depth of the footing? Only will see in gamma D NQ only. So as obviously in this equation, if your depth of the foundation or depth of the footing is increases, then obviously this term will increase. Then obviously that leads to the increase in the ultimate bearing capacity. Suppose if you are constructed footing on the ground surface, then what about your depth value? Your depth value will be equal to 0. Even if you are having depth is equal to 0, it will have some capacity, it is how much equal to CNC plus of gamma B and gamma. So this is matching with the reality. Okay. So if your depth of the footing increases, what can we finalize from here? If you increase the depth of the footing, then your bearing capacity will also increases. Okay. Next. What about the width of footing? In width of footing, what we can say? But in how many terms we can say the width of the footing? Only in one term, that is again half into B into gamma into N gamma. Again see here, if your width of the footing increases, then obviously your ultimate bearing capacity will also increases. Okay. Now coming to the relative density, or we can say it as a density relative nature. So what is the use of relative density? The use of relative density is to define how much soil is compacted. That means if the soil is more and more relative density, it is having more and more get compacted. If it is having more and more compacted, then your phi value will also increases. How the phi value is affecting the ultimate bearing capacity equation? Have you seen any 5 term in the ultimate bearing capacity equation? No. But your phi value, depending upon the phi value, how many terms are dependent? Your NC is dependent, your NQ is dependent, and also N gamma is also dependent. If your phi value increases, then these terms will also increases. That means if your soil is more compact in nature, your angular friction will increases. If your angular friction is increases, then obviously these constant NC, NQ, N gamma are also increases. If these are increases, then ultimate bearing capacity of the soil will also increases. Okay, this is what about the factors that are affecting the ultimate bearing capacity. In the next video, we will see how the size of the or how the shape of the footing is affecting the bearing capacity equation. So as of now, we have talked only for the continuous footing, right? But if there is a rectangle found footing, circle footing, square footing. So for those types, how the bearing capacity changes, that we will see in the next video. Thank you.